let's talk a little bit about iteration. And you might be thinking, I don't even like the sound of that word. I think you'll like this. We're going to keep things real simple. We're going to explore some very interesting things, create some beautiful images, and you'll be able to understand it. We'll just take it one little step at a time. Tonight we're talking about iteration of functions. And I want to recommend three books. And these books are written for hobbyists or lay people, not for mathematicians or professional people. The first one is called Chaos, Fractals, and Dynamics. Wonderful little book. And this is actually, the subtitle for this is Computer Experiments in Mathematics. So that sounds pretty darn technical, but you can work your way through this. And that's a good text to have along with this video series that we're going to do on iteration. Another one is a very famous book, James Gleick, Chaos, Making of a New Science. Very easy read, very interesting read, and he does a great job at explaining things. Again, you don't have to be a math major to enjoy this book. And a third one, I think, and I have all three of these in the bibliography at the bottom of the page here. This one is called The Mathematical Tourist. Snapshots of Modern Mathematics. And again, it's a fun book. And it's a layman's book. It's a hobbyist book, not a, you don't have to be a PhD to understand that. And I also have for you on the website at rickmckeon.com two figures to go along with this particular lesson. This lesson is an introduction. So these two figures, one is called iteration, and I know you probably can't see that very good on the screen, but it's on the website in a PDF format. And the other one is called Figure 2, Graphical Analysis for the function f at x equals the square root of x. And we're going to demonstrate this on a calculator, and we're going to demonstrate this graphically too. So, here we go. Iteration of a function. Normally you have a function and you have an input to that function, some number, some x value say, and you work the function on it and you get a result. That's called the output. Now this could be a function like, let me just draw a graph here. If this is the x-axis and this is the y-axis, maybe we have a function that looks something like this. And I would call this y equals x squared. So where does that come from? Well, for every single little value of x, we're going to square it and we get a y. So if we did this for all the negative ones and all the positive ones, we'd get a graph that looks something like this. That's where these graphs come from. And they could have different shapes to them depending on the function. So we have an input, we work the function on it, and we get an output. And that's 1 for 1. This value of x is a negative number. We square it and we get this value. This value of x, which is a positive number, we square it and we get this value, and so forth. And of course, x squared means x times x. So it gets a lot, this is going to get a lot bigger than what we have out here in terms of x. So that's a function and the graph of a function. Now, here's where we get into iteration. Instead of just taking an input, working the function on it, and getting an output, and then just doing that for every possible value of x, and to do that, to create a graph, you don't have to do it for every possible value of x, because there's like an infinite number of them. So you just do it for several, and then you can kind of connect the dots up, and you get a graph. But What happens if, instead of just doing that, we have an input and we get an output, and then we take that output and we feed it back in again. So the output becomes the input again, and we work that function on it, and we do it again, and we do it again, and we do it again. That's called iteration. And we get a string of numbers. And the string of numbers that we get, it could go way up, it could go huge, it could go to 0, it could stay where it's at, it could bounce back and forth between a couple of values forever. In other words, if we had like this, the one we showed you for x squared, if we had started with the value 1 and we squared that, well, the output's 1. If we feed that back in, it's 1. And we're going to get another 1 and so forth. Sometimes the value can explode and it can get really big. Sometimes it's going to tend towards 0. Sometimes it'll tend towards some specific number. All depends on what we start with. But iteration is, you have an input, you work the function on it, you get an output, and instead of stopping there, you go ahead and work that function on that output. And then you work the function on it again, and you get a whole string of numbers. And that string of numbers is called the orbit for those iterations. Now, we're going to take a calculator, and we're just going to demonstrate that. What would happen if we had the function was the square root of x? So f at x is the square root of x, or y equals the square root of x. And we pick some number, say between 0 and 1. What happens to that number as we do it over and over again? We're going to see that with a calculator. Let's do that right now. Alright, so let's see how this works on the calculator. This calculator has a square root function. Right there is the square root button. And let's say that we start with a seed value, a beginning value of 0.4. 0.4. Now, when I hit the square root button, we're going to take the square root of 0.4. And we get 0.63. And of course it's a long decimal number, but let's just work with the first couple digits there. That's the output of the function, square root, when it's worked on 0.4. We're going to take that as the new input value, hit the square root again, 0.79. Do it again, 0.89. And I think you can see where this is heading. We're heading actually for the number 1. We don't actually ever reach there, but we get closer and closer all the time to it. So the number 1 would be the limit of this orbit as we're approaching it. Hit it again, 9.4, again 9.7, again 9.8, and so forth. And eventually we'd get very close to the number 1. So we're iterating the square root function by taking the previous result and taking the square root of that. Take the next result, take the square root of that. And that series of numbers is the orbit of this iteration, approaching the number 1. Try it yourself with different numbers, say between 0 and 1, and you'll see that they always start to approach 1. We're going to see how that works in the graphical analysis. Okay, so that's what happens when we keep hitting that square root button on the calculator. We are iterating the square root function. We start with 0.4, and you could start with other values, and you could see they would tend toward the number 1. Let's look at it graphically once. This is pretty interesting. This is a lot of fun. I've drawn two things on the board here. Of course, we have the x and the y-axis. This is the x-axis, and this is the y-axis. And I've drawn a line, a straight line, kind of cutting that thing in half. This would be a 45-degree angle. So this line is called y equals x. Everywhere on this line, x and y are the same. Now, especially, here's an interesting point, where x is 1 and y is also 1. Of course, it's on this straight line, but this is the place where this function of the square root of x intersects that line. Okay, that's kind of an important point. So, we're going to take some value in between 0 and 1, and let's just see what happens graphically. So this is a way to illustrate iteration graphically. Here's our first point, our what's called a seed value. This is x sub 0. Well, we take the square root of x sub 0, we get this point right here. On this graph, f at x equals the square root of x, or y equals the square root of x. So this point I would call x0, y0. By the way, this is figure 2. Okay, so this is drawn out for you, and it's going to look a lot better in the figure than it does here on the board. I'm just not that artistic. If I do it with a computer, you know, a graphics program, that comes out pretty good, but I'm just doing it by hand now. So this is figure 2. Alright, so here's our first value. We started with some point down here, x sub 0. We worked the function on it, and we ended up with x sub 0, y sub 0. And so we said for iteration, we're going to take that value and do it again. Well, where along this x-axis is that value? Here's the line x equals y equals x. And so what I'm going to do here is just going to go right on over to him, straight over. And x and y are the same here, so this becomes x sub 1, our new x value. And if we work the function on this x sub 1, we get it right here. So this is going to be x1, y1. You can see what's happening now. Where's our next x value? Well, it's going to be right here. I'm going to drop him down for x sub 2. And we work that on x sub 2, and we get a x sub 2, y sub 2. Right there. And so forth. So this is a graphical representation of these different x values as we keep working the square root of x function on those values. Just like we saw on the calculator, we're getting closer and closer and closer to the value 1. And I think you can see graphically, if we did this starting any other place, they're all going to go that way. They're all going to work toward 1. In fact, and this is a good exercise to try, if we started out here and we work the function, we're going to go back toward 1 that way, from above 1 back to 1. Now, this is just one simple function of y equals the square root of x, f at x equals the square root of x, but this could be done on many different functions. And I'm going to provide for you some graphics and some tables illustrating iteration on different starting points for different functions. So, in summary, what do we have? Iteration of a function is taking the seed value, the first value, the input, working the function on that, and you get a result. Take that result, work the function on it again, and you get another result. Take that result, and again, over and over and over, and you generate a series of values. And what's going to happen with those? Who knows until we do it. They could get, they could approach 1 being the limit here, or they could blow up and get huge. They could go to zero. They could stay the same, depending on where we started, or they could bounce back and forth. Here's where we get to some interesting properties of iteration of functions, depending on the starting value. And what we're going to do as we go along is we're going to color code those points, and the longer it takes for them to escape or get like really huge or to get to some stable point, we'll assign a color to them. And we'll do a couple of basic programs. When I say basic programs, I mean basic like simple, but I also mean like basic language, okay? And maybe we'll do some C programs too, for those of you who are familiar with the C programming language. And you think, oh man, this is like getting too technical for me. It's not, okay? It's going to be pretty simple. And we're just going to have a lot of fun with it. So this is the introduction to iteration of a function. If you have questions, if you're interested but you still have like some questions I don't understand, go ahead and shoot me an email and I'll see if I can answer your questions.